Great. Well, let's go ahead and get started. Thank you to each of you for joining us today. Welcome to the first webinar of our new SEER webinar series. The topic of today's webinar is regional surveys to improve understanding of ecosystems and relevance to offshore wind energy development. The goal of today's webinar is to provide a review and updates on ecosystem level or big picture considerations for large-scale wildlife surveys and species density models to explore the relationship between these survey and modeling efforts and offshore wind development in U.S. waters. My name is Rebecca Green, and I'm a senior scientist with NREL, the National Renewable Energy Laboratory, and will be facilitating today's webinar. I'd also like to recognize Michael Richland from the Pacific Northwest National Laboratory, or PNNL, who has co-organized this webinar with me. Today's webinar is being recorded and will be posted on the TETHIS SEER website for future viewing. Next slide, please. By way of agenda, we'll first have an introduction providing a brief SEER overview of SEER topics to date and welcoming remarks from DOE. We'll then have presentations from our panel of experts for about 10 minutes each, including Andy Lipsky from NOAA Fisheries, who will talk about NIMF's Northeast Fisheries Science Center surveys in this new era of offshore wind energy development. Tim White from BOEM, who will be talking about BOEM's marine assessment for protected species programs, and Pat Halpin from Duke University, who will be speaking about from surveys to models, habitat species density models informing offshore wind development for the US Atlantic coast. We'll then have a panel discussion, including audience Q&A for about 20 minutes, followed by brief closing remarks. Next slide, please. So first, I'd like to provide a brief introduction and overview of our SEER project to date. SEER stands for the U.S. Offshore Wind Synthesis of Environmental Effects Research Project. At the direction of the U.S. Department of Energy's Wind Energy Technologies Office, our two national laboratories, NREL and PNNL, are jointly leading this multi-year collaborative effort to share information on the environmental effects of offshore wind energy and to help prioritize future research needs. The overarching goals of our SEER project are to synthesize and disseminate the international understanding of environmental effects, including monitoring tools and mitigation strategies for offshore wind energy development and how it applies across US regions. The SEER team is also identifying any remaining knowledge and research gaps, and overall, sort of at the highest level, we're working to collaborate with regional experts and any existing science entities to fully leverage community expertise. These are 7 of the topic areas shown on the slide here, where we've developed regional educational research briefs on topics all the way from introduction of new structures and effects on fish ecology through looking at benthic disturbance from foundations, anchors, and cables. Next slide, please. To date, the primary SEER products have included a series of educational research briefs, which I referred to on the last slide. These briefs review the state of the knowledge on stressor-receptor interactions, monitoring methods and technologies, mitigation measures, and cumulative impacts. We then hosted a follow-on webinar series a little over a year ago to disseminate the findings presented in the research briefs and to share latest research, including minimization and monitoring strategies, together with panels of experts for each webinar. And finally, we've developed databases with research recommendations to summarize information gaps, barriers, and current challenges for both the US Atlantic and Pacific coasts. SEER has been ongoing for a little over 3.5 years, and we're expanding efforts including now into the Gulf of Mexico region. So next up, I would like to introduce Joy Page. Joy is the Environmental Research Manager for the DOE Wind Energy Technologies Office and is the Program Manager for many projects, including our SEER project. Joy previously served as the Director for Renewable Energy and Wildlife for Defenders of Wildlife. Welcome, Joy.
Thank you, Rebecca. And I'll be brief because I'm really excited to get to our panelists. So once again, hi, I'm Joy Page. I manage the Department of Energy's environmental investments for land-based and offshore wind, which, as Rebecca mentioned, includes SEER. As many of you have heard me talk, we're very proud of the work of SEER at DOE, as well as really invested in the specific topic of today's webinar. As many of you know, the administration has aggressive goals of 30 gigawatts by 2030 and then 110 gigawatts by 2050. And to get there, we know we're going to need to better understand the impacts and benefits of offshore wind so we can do it sustainably. But we also know that time is of the essence, and we really need to be doing this in an efficient manner. So we'll have to do this in partnership across federal agencies, academia, industry, and other stakeholders. And this is a huge part of why we invest in SEER. And the webinar today is exciting because it highlights 3 of these key partners talking together how we can be working better for regional data, collecting regional data and making defensible conclusions. And what's great about the lineup is it features 3 individuals that are working together right now on this topic. So DOE and BOEM have funded Duke University on the WOW project, the Wildlife and Offshore Wind. And Pat's going to talk more about it, but they've created a framework for regional monitoring and will very soon in the next day or so start collecting some of that data. Pat is an important co-PI on that project, and Tim and Andy have been key advisors on this as well. So I'm really excited to hear from them today. So thanks again, Rebecca.
Super, thank you, Joy. And as Joy said, we're excited to launch into our panel discussion today, beginning with presentations from each of our speakers. So thank you very much to Andy, Tim, and Pat for joining us today. We'll first have approximately 10-minute presentations from each speaker. We'll then launch into a panel discussion and participant Q&A. So as you think of questions, feel free to put them in the chat, and we'll get to them during the second half of today's webinar. Our first speaker today is Andy Lipsky. With over 25 years of fisheries and renewable energy experience, Andy has worked at the NGO, private industry, state, tribal, and federal levels. Andy joined NOAA's Northeast Fisheries Science Center in 2016 and currently serves as the center's offshore wind science lead. So with that, Andy, please take it away.
Rebecca, can you see my slide?
Yes, we can.
Awesome. Yeah, I can't see anything except you. Thank you so much for the introduction, Rebecca and Joy. I'm going to talk a little bit about fisheries, wildlife, and ecosystem surveys conducted by NOAA Fisheries in this new era of offshore wind energy development. It should have gone to the next slide. Did that happen? So I'll start with the new era part of this, and Joy provided a lot of the context. The US and other countries across the globe are utilizing offshore wind energy, both existing technologies like fixed foundations and new technologies like floating as a central plank in our world's decarbonization efforts. That said, this is a massive new expansion of marine energy development across the shelf, with a 3.5 times increase for fixed foundations in terms of announcements across the globe by 2027, and a 68 times increase for floating. So to do this well, we need good information and data. Our regional surveys provide that context, which is critical for sustainably developing offshore wind energy. Our regional surveys are also interact with this offshore wind energy growth, and the potential interactions with the marine environment make our regional surveys very important in terms of providing context to population level impacts. Just a quick slide of what this growth and development looks like in the North Sea, where offshore wind began. When we look at the US, we have roughly about 50 million acres in planning areas, about 2.6 million acres across the US in leases, with many leases already awarded and announced in the Northeast region, where I'm going to focus predominantly focus my talk in the Northeast region, but also recognize that I have colleagues in the Gulf of Mexico and the West Coast at my sister regional offices and science centers that are addressing offshore wind energy science needs similarly to us. So offshore wind energy interacts with basically every part of our Northeast fisheries science enterprise, from the communities where development is happening, to the trust resources like right whales, to our regional surveys, which I'll spend the majority of my talk, and many of our customers and our mandates, such as providing safe and another type of renewable energy source, seafood. So NOAA's role in offshore wind energy is really in 5 areas. Our regional surveys are relevant to all these 5 areas. We support the offshore wind development process itself, led by Bureau of Ocean Energy Management. And we provide scientific and technical support to those regulatory and planning processes. Our regional surveys come into play in these areas. The other area that we are involved in is actually mitigating the impacts of wind development on our surveys and assessments and data enterprise themselves, which I'll go into in a few slides. We also are very interested in conducting research to understand the impacts on our trust resources, fishing communities, and protected species as notable examples, and also mitigating unavoidable impacts on our trust resources. So what are NOAA Fisheries Regional Surveys? So under the Marine Mammal Protection Act, Endangered Species Act, the Magnuson-Stevens Fisheries Conservation Act, and the Fish and Wildlife Coordination Act, NOAA Fisheries has a number of congressional mandates that we need to meet. And our scientific surveys inform our management responsibilities to meet those mandates. Based on our mandates, our trust resources, our surveys support the assessment across the US of over 500 fish stocks and stock complexes, 120 marine mammal species, and 160 threatened and endangered species. Many of these regional surveys are standardized, have occurred for over 30 years, and we have over 50 of them across the US. And I'll get into a few of those examples. Some of the qualities of these surveys: they seek to reduce uncertainty to improve management, and we look to increase the accuracy and precision by maintaining the consistency of the surveys over time. Consistent sampling designs and methods are actually an essential feature of the value of these surveys. And they allow NOAA, through our congressional mandates, to examine the status and trends of our trust resources, our habitats and ecosystems, so we can manage them sustainably. So in the Northeast region, which I'll focus in on, we have actually like 541 years of total survey effort, about 14 regional surveys, some of them beginning in the 1960s, and some of them starting in 2010, such as the Gulf of Maine Cooperative Bottom Longline Survey. So these surveys have been conducted for many of them for decades, using the same sampling designs and methods. Examples on our West Coast, we have 13 surveys, regional surveys along our West Coast that also overlap with areas of potential leases and future areas being considered for wind development. In the Northeast region, many of these surveys have various survey designs, and they have major applications. Most of these applications are about measuring abundance, providing biological information, providing ecosystem scale information, abundance distribution, and vital rates for organisms in order for us to effectively manage for them. The Atlantic Marine Assessment Program for Protected Species, I won't get into too many details because Tim's going to be covering this. This is a collaboration with BOEM, U.S. Fish and Wildlife, and Department of Defense. But we've been doing this since 2010 in 5-year increments, where we do broad scale abundance estimates. We collect more finer scale data on life history and ecology of key trust animals, telemetry data, and abundance and distribution data. So during the Vineyard Wind 1 project NEPA evaluation, we identified the development of offshore wind energy would impact our ability to carry out our surveys. It would be a major impact. And this impact happens in 4 ways. Preclusion, because our platforms, such as our aircraft and our vessels, will be displaced by the infrastructure, won't be safe to fly at an elevation of 600 feet if the turbines go up to 1,000 feet. And the spacing of the turbines make using our white ships very challenging deploying our mobile gear. It also impacts our statistical survey design, whether it's fixed transect or random stratified sampling. And another impact is the effect of the habitat effect of the large scale habitat changes, whether they're positive or negative or none at all. If the variance structure inside wind energy areas are different than the variance structure outside wind energy areas, it can introduce bias into our estimates of abundance. The other 4th impact are the efficiency of our sampling by increasing the amount of sea days needed or aircraft hours needed to fly during low cloud cover. The implications of not addressing these survey disruptions are profound across the public and many of our constituents. We fortunately recognize this issue and work with BOEM collaboratively to develop a strategy for the Northeast region to look at how we can evaluate, design new methods, calibrate old methods with new methods, bridge solutions, and implement new surveys, and communicate these new data streams and develop new data streams in order to mitigate the impacts of development on our surveys. So coming soon, we'll see Gulf of Mexico and the West Coast also develop survey mitigation strategies, survey mitigation programs, and survey mitigation plans. And you can see in this chart that we're the very beginning steps of addressing the implementation of the strategy. For implementation, we're developing survey mitigation plans for each of our surveys. We're looking at developing new surveys. This is for the Northeast region. And we're for both our fisheries and our protected species surveys that range from new surveys like hook and line surveys to trap video surveys, eDNA surveys, and also passive acoustic monitoring surveys. In closing, I would suggest that to do this well is going to require national, regional, and international collaboration and new partnerships, and also leveraging existing partnerships. But the challenge is real. There's a steep learning curve that needs to happen because we need to modify our surveys at the same time of rapidly advancing offshore wind energy. We have new stakeholders and we have new resource needs. In terms of some outlooks for the NOAA fisheries and BOEM survey mitigation implementation strategy, we're standing up an implementation team, developing project level standardized monitoring requirements, an interagency resource plan to support survey mitigation. In review is a paper on evaluating project level monitoring in the Northeast to mitigate impacts on our regional surveys, and also more specific survey simulation experimentation and evaluation projects through our cooperative institutes to look at changes to our spring and fall bottom trawl survey. With that, I'd like to say thank you, and I'll take questions at the end.
Super. Thank you so much, Andy, for that review of the wealth of survey effort that NOAA's completed and maintaining your incredibly important mission moving forward with offshore wind development. So next up, we have Tim White. Tim serves as an avian biologist with BOEM's Environmental Studies program. He manages multiple ecosystem-based monitoring studies for BOEM, including the Atlantic Marine Assessment for Protected Species Program and other projects, which we'll hear about today. And Tim, we can see your slides if you just want to go into presentation mode. Thank you very much.
Okay, thank you very much, Rebecca. My name is Timothy White. I'm an avian biologist, as Rebecca said, in BOEM's Environmental Studies program. I'll just click back to my first slide here. And I'll be talking about a high-level overview of our MAPS project, which is our our Marine Assessment for Protected Species program. So we have first created the Atlantic Marine Assessment for Protected Species program, and then that branched out to the Gulf of Mexico MAPS program, and then the PAC-MAPS program. They're essentially broad scale baseline studies of higher trophic level predators, prey, zooplankton, seabirds, whales, sea turtles. So where I sit in BOEM, in our environmental studies program, we conduct the studies here, the studies coming from the regions, with the emphasis on studies centered around offshore marine mineral development, offshore wind, oil and gas. This map here, I wanted to point out that we conduct our surveys. We have billions of acres of ocean under our jurisdiction, and recently we acquired a jurisdiction of the territories here highlighted here within the U.S. economic zone. The Outer Continental Shelf Survey is basically, if you look at the East Coast, that's where our AMAP surveys are conducted, even into Canadian waters at some times. Our environmental studies program has been here since 1973. Again, our studies are feeding into multiple offshore wind energy projects, marine mineral development, oil and gas development, assessments, plans. We've been here since the studies program has been here since 1973. We've contributed over 1.25 billion in research since then, every year about $30 million in funding. But we do our studies by interacting with all you folks, scientists, through interagency agreements, as Andy was pointing out, cooperative agreements with academics and NGOs, competitive contracts, again, with industry and NGOs. We couldn't do these studies without you. It's an enormous undertaking. And every year we have the studies program. There's a call for study ideas, and the cycle begins around Halloween and ends around about the August, September time. As the studies come in, they're developed. Some of them developed from stakeholders, and we review those, develop those, review those, and then they're distributed out to and developed into projects through these mechanisms, these funding mechanisms. So first off of the AMAPS program, the Atlantic Marine Assessment Program for Protected Species, that was developed, created in 2010, and it's in its third phase, possibly a fourth phase. We're in the third phase now, and we cover a broad suite of topics, from ship-based surveys to aerial surveys to looking at plankton and fish with tows, physical oceanography with CTDs, passive acoustic monitoring with towed arrays and bottom-mounted arrays, tagging birds, turtles, whales, cetaceans, also using eDNA, and Andy pointed some of that out because NOAA, Northeast Fisheries Science Center, is doing a lot of the work along with Fish and Wildlife Service, USGS, Department of Navy. The Navy is with us as well. We're on the coast to the shelf break, from Nova Scotia down to the Straits of Florida on the Atlantic EEZ. So we're really conducting using a wide suite of innovative techniques and long tried and true techniques. This is an example of a product output from our ship-based surveys and aerial surveys on the NOAA side, NOAA segment of AMAPS. That was common bottlenose dolphins. That's the map you see here with the observations and some course level footprints of the wind energy areas. But this slide gives you an example of the aerial over shipboard surveys, and just AMAPS 2 alone, of how much effort we've conducted and just how many sightings and samples we've collected from mammals, seabirds, and eDNA, bongos. It's been incredible data collection, unlike any other program. All this data is publicly available, from the raw data to the models. This slide represents the fish and wildlife component of the AMAPS program. We've traditionally used observer-based aerial surveys, and AMAPS 1 and 2, and AMAPS 3, we transitioned over to built out high-resolution cameras, sub-centimeter imagery, and using AI ML deep learning algorithms to automate the classification and detection of seabirds, turtles, and cetaceans. This is an ongoing study. We go out regularly to collect imagery and then feed that back into training models. This is an example of one of our annotation tools that we're using to go through and annotate the imagery for training purposes. GoMaps. This is where GoMaps came after AMAPS in the timeline. And again, we're using very similar design, very similar aerial surveys, boat-based surveys, methodologies to survey, understand the distribution and abundance of cetacean seabirds, sea turtles in the Gulf of Mexico. This slide here is an example of the Fish and Wildlife planes, the Kodiak Quest with floats. This survey design is hexagonal with survey transits within the hexagons as sampling units. Again, here this is how we collect for seabirds, and USGS is also collecting sea turtle imagery from these planes, and we have 2 observers on both sides of the planes observing and recording into a record transcribe audio program that is then transcribed to CSV files with your essential data streams, species lat long, so on and so forth. This data is converted, analyzed, and predictive models are created. This is an example of a northern gannet distribution and abundance model derived from the aerial survey estimates. We also are partnering with the Southeast Fisheries Science Center to go out and use their boats and with their teams and observers to collect distribution and abundance data on marine mammals, seabirds, and turtles as well. And this is a different footprint of the survey area. It's quite extensive. The boats get to places where their planes could stay out longer and use different suite of tools to sample the water column. And these are some of maps that were spawned from the ship-based surveys, Audubon, Shearwater sightings, top right, and Audubon, Shearwater's models, predictive models in the bottom right. And some of this work has resulted in compiled and integrated together to form seabird models. This is an example of a paper produced by our partners that produced an annual seabird model of 23 species, and you can get an idea of the patterns and sort of the intensity of the seabird distribution in the Gulf of Mexico from these surveys, which we did not have before. Pack maps is very similar, just briefly going through that, very similar design, boat-based surveys. The maps here represent the Hawaiian archipelago, ship-based transit designs. We're completed Pack Maps 1 from Washington down to Southern California, and we're starting Pack Maps 2 and partnering again with a lot of existing NOAA surveys to complete this mission. But without all of you, we couldn't do the work, of course. Partners are vitally important for what we do and the science needs that we have for our Bureau. And again, it's all of the feds, many different federal agencies, but also academics and scientists across the board in industry. We all need to work together to accomplish these big goals. Thanks very much. And feel free to reach out to me with any questions or about our studies or how to get involved, our studies development plan, or any data requests that can point you in the right direction.
Thank you, Tim, for that great presentation on the evolving maps programs and the incredible history of the environmental studies program. Great. Next up, we have our final presentation, and then we'll go into Q&A. Next up, we have Pat Halpin. Professor Patrick Halpin leads the Marine Geospatial Ecology Lab at the Nicholas School of the Environment at Duke University. Professor Halpin's research focuses on marine geospatial analysis, marine spatial planning, and ecosystem-based management. So with that, I'll hand it over to Pat.
Great. Thank you so much. Hopefully you can see my slides okay.
Yes,
Great.
indeed.
Excellent. So I'm going to build directly off the last two presentations and talk about from surveys to models and thinking about products that we create from these surveys. So I'm going to be trying to look at that transition on creating habitat-based species density models and specifically use cases informing wind development in the US Atlantic. I have many colleagues from my lab group, so Jason Roberts and Tina Yak have been actively working on the model development, and Debbie Brill and Jesse Cleary working more on the overlays with wind energy development. So I definitely want to note their fine work here. So thinking about how do we take the survey data and make use of it for wind development monitoring, we really think about the models as providing information on the spatial question, the where question, where are the animals, but also the temporal question of when do we see them. And these are very, very important, especially dealing with seabirds and cetaceans and bats and other species, because our focus is pretty different. So we're thinking about seabirds often as more of a year-round interaction with potential wind development. Cetaceans also year-round, but really kind of peak periods of construction and maintenance that we feel is going to be really active times. And so really the timing of when species are going to be on site is going to be very, very important. So it's really the when and where questions. For Project WOW, which is a DOE BOEM funded project that's just getting underway. As a matter of fact, the field surveys for that project are hopefully going to start very, very soon. We're looking at an assessment framework. So I thought I'd start with this risk framework as a touchstone and how do models fit into this framework. And so we think about risk assessment in kind of an impact chain, starting with occurrence of species, and then calculating the exposure of the species to any kind of noise or other kind of activity, and then thinking about their potential response. And then finally, what is the consequence of that response? Species models built from these surveys really give us information on the occurrence part. It lets us look at where and when the animals we think are going to be in the region, in the area, and gives us a little bit of the beginning of the idea of exposure, not fully, but it lets us start to look at how we would assess exposure and what do we anticipate. So when do we anticipate months of the year when lots of animals might be on site or close to wind development? So just to dive in a little deeper, the surveys that we just heard about give us this animals in space and time, the raw data. The habitat models are how we take a lot of that raw data and try to turn it into information to answer specific questions. And with wind development, we're really thinking here about some information that helps us think first about exposure scenarios. And then this first part of this exposure scenario, thinking about when do we think animals are going to be in the wind areas, but also what proportion of the animals' distribution is going to be potentially impacted by wind or interacting with wind. So we've heard about these different surveys and shipboard and aircraft board surveys. So we just heard about the AMAPS project as an example. And these are surveys that need to use very, very strict spatial protocols. The question here is to develop data that can allow us to build density models, the actual abundance and density of animals, which is very different than just a habitat model. So trying to get a count of how many animals do you think are on the surface and how many are underwater at any given time is something that requires us to record not just occurrence of animals, but also a lot of geometry. So these are very, very detailed types of surveys. And so it's a different class and category of type of survey. They also differ quite a bit. So shipboard surveys are going to have different kinds of crews, the different height of the vessel. Aircraft surveys are going to be moving at very different rates of speed. They're going to have different types of observers. So there's quite a bit of difference between these kinds of platforms. For the project I'm talking about right now, we aggregate together many, many, many different surveys. So we just heard about NOAA and BOEM and the MAPS surveys, but we also aggregate in and augment those surveys with many other independent surveys from other federal agencies, but also NGOs and other academic groups, many of them targeting specific kinds of information. So this map here is showing, I believe, 13 different survey programs that are integrated together. This is a huge effort and a lot of collaboration, and this would not occur if we did not have really, really strong collaboration between many groups that are willing to openly share their data. So we thank all our collaborators. The efforts I'm talking about on this survey aggregation and modeling are actually mainly funded by the US Navy and with some projects funded by NOAA. The products from these are directly being used in wind energy efforts that are funded by DOE and BOEM. So there's a lot of different collaboration as well, intermingling products that are created from different agency funding streams. So we're thinking about modeling density of animals, and here I'm looking at right whales. We start out with survey data. So this is an aggregation of many different kinds of surveys, aircraft and shipborne surveys. And then thinking about trying to take that and turn that into a density surface model that allows us to estimate how many animals are per square kilometer or 100 square kilometers in a region, and using an oceanographic and physical modeling system to be able to create a model that drives this through time. And so we're thinking about monthly time steps. We create both density surfaces, but also uncertainty maps that allow us to interpret or better interpret the outcomes as well. So it's not just the density mapping, but the uncertainty maps that are extremely useful. Density surface modeling is extremely detailed subject, but I just want to give a very high level overview of really two phases. The first stage is really thinking about the detectability of animals. So we have to take the survey data and then try to estimate how many animals would actually be seen. And this is just an example of this idea. Here we're looking at, imagine you're on a vessel, you're looking at binoculars, and you can definitely see the animals close to the track line of the vessel. You can see some farther away, but then after some period of distance, you're going to start kind of squinting and wondering, is that actually an animal or a wave? And so that detectability is something we need to model very carefully because it's a multiplier in the model. And it really lets us see, how many animals would be seen. And it's affected by several things. One is going to be what we call perception bias, how the animals would be observed. So things like the Beaufort sea state, sun glint if you're an aircraft, how the speed of the vessel of the aircraft, all these different things affect what you could actually see. But then also the animals themselves, availability bias. Deep diving beak whales are underwater for long periods of time, so you're not going to see as many of them as dolphins at the surface. And so all these things are a huge amount of work goes into trying to tease out in the statistical models to be able to do a better job of correcting for these biases. The second portion is actually conducting the spatial model. And with this part, what you're thinking about is taking covariates. Many of them are oceanographic dynamic covariates. Some of them are physical benthic conditions, putting them into a spatial model to actually make the predictions and the uncertainty maps. Now, what we have here is an example of the outcome of one of these models. And on the right side is a 12-month model for North Atlantic right whale. And so we're animating through the months of the year. So M1 is January, so it's going through the months of the year on the right side. And for context, we're looking at two wind areas, Vineyard Wind and Empire Wind. And the kind of framework we're using right now is to think about this. It's not just a spatial problem, but also thinking about the time series. So those plots showing the curves is showing the expected abundance and density of animals that you would expect in the wind areas and a 10-kilometer buffer around them through 12 months of the year. To go back to our modeling framework, we also felt that it's very important not just to be thinking about when would animals be on site in a wind area, but also what proportion of their total population, of their regional population, would we expect to be in that area. So this next plot here is just digging in a little deeper to show this North Atlantic right whale example for vineyard wind, looking at a plot where the orange line is the wind lease area through time. So that's 12 months of the year. And you can see during early spring, winter, and spring months of the year, there's potential for having North Atlantic right whales traveling through that area within a 10-kilometer buffer. But then in the summer months, we see a low period of almost no animals predicted. And so this gives us a much better idea for thinking about the monitoring we would need to do and the expectation of when you would have animals on site. The context is allowing us to look at here in time, the low and high periods, but then also these green lines are looking at the abundances you would see in different regions. So you can have a comparative to say, is that a large number of North Atlantic right whales compared to what you would expect as the regional density. And we've also been doing this for many species of marine mammals, cetaceans, and also working with NOAA INCOS on seabird distribution models to do the same kind of work with seabirds. So this is allowing us to get this temporal kind of picture of when and where we would expect animals to be on site in these wind areas. One of the last things I want to comment on is that all the models that we're putting together, similar to the raw AMAPS data, we put all the models online and make them publicly available. So under the OGUS CMAP site that our lab runs, we have a model repository. This is funded by the Navy and NOAA. And we have new East Coast models. These are recent 2023 models that have been updated for around 30 species of cetaceans for the Atlantic coast. All of these models are also then ported through web services to the Northeast Ocean data portals and the Mid-Atlantic data portals for ocean planning processes. So just to recap, habitat-based species models allow us to combine survey data and estimate the expected occurrence of species in wind areas. These models can directly provide information that's useful for both planning and timing of construction activities, as well as expected baselines for monitoring. These models allow us to estimate the type and intensity of monitoring you would need through power analysis that we can conduct that would allow us to look for observed effects. So if we have a baseline, we can look to see, do we see a change? Is the development of wind energy displacing animals or not? And then finally, ongoing work is underway right now to increase the spatial and temporal resolution of these models to better forecast subregional distributions. And this is something we see as a long-term activity into the future. Is how can we build models that are going to allow us to look more finely in space and time for these questions. Thank you.
Excellent. Thank you, Pat. And those were three wonderful presentations setting up our what's currently happening by way of surveys and species density modeling related to offshore wind energy development in U.S. waters. So this brings us to the Q&A portion of our webinar. I have a couple of questions I'd like to start out with, but please go ahead and put any questions that you have in the chat or go ahead and raise your hand. And actually, Scott, I see that you do have your hand raised, so we'll start with you. Scott Johnston. Scott, I believe you have your hand raised, although that may or may not be an error. While we wait to figure that out, I am going to ask a question. This is for both Andy and Tim. How do you see regional environmental surveys changing in response to future, so longer term development of offshore wind energy across U.S. coasts? And this is a pretty open-ended question about how you see regional environmental surveys changing, whether it's changes in survey designs or new technologies that might be needed related to fixed bottom build out, future floating build out, and taking different regions into account. So Andy, we'll go ahead and start with you, please.
That's a good question. We ask that question to ourselves every day. So it's a massive challenge because we're not going to be able, depending on the advice we're giving and the stock we're managing, the population we're providing advice for, the impacts of wind development will be different. But we know that our survey enterprise will be disrupted. So it's a massive challenge, but it's one of these cliches. It's also a great opportunity. Even without offshore wind development, we try to increase the precision, accuracy, and timeliness of our observations by advancing new technologies. And we're going to have to advance new sampling platforms and designs. We're in the process right now of developing an uncrewed HabCam unit so we can continue to monitor the Atlantic scallop population, one of the second valued fisheries in the United States, which will allow us to collect remote sensing or optical and video imagery, so we can continue to manage scallops. So these more remote sensing techniques, acoustic surveys, for instance, we rely more on telemetry studies so we can understand behavioral changes. I mentioned some of those. I had one slide, I went really fast, some new surveys that we are developing plans to do these. We don't currently have sufficient resources to begin a new time series, but we're doing the planning efforts right now to define how we can address this challenge. We can address this challenge. BOEM and NIMS have worked together to develop our survey strategy in the Northeast. We'll see other strategies emerge in the Gulf of Mexico, in the West Coast, where my colleagues and counterparts will be developing similar approaches. But we're all in this together, and we're going to have to work fast to meet the pace, scale, and magnitude of development. But advanced sampling systems, uncrewed systems, and calibrating new surveys with old surveys are sort of some of the things that we're thinking about.
Thank you, Andy. And Tim, I'd love to hear your answer to that question. And then Scott, we'll loop to your question now that you're unmuted.
Yeah, sure. And yeah, just to build upon Andy's response, it's true that just with this footprint and tall wind turbines, we're thinking about this now, being proactive and building out, developing the high resolution camera so we can fly higher and actually detect more, with sub-centimeter imagery. And as we have the imagery, we just can't have teams of human beings combing through the imagery, taking years. So these automated processes, such as AI, ML, deep learning algorithm for detection and classification of what we're seeing with the cameras, it's very important. And if those CubeSats we're trying to develop, work with different agencies and partners to develop smaller tags, GPS tags, say if you think about small birds. And that's sort of the CubeSat innovation has really helped us open that field up for higher frequency pings with smaller tags. So that's very helpful. And even eDNA, it's a new type of net. We can sample the water column. We just have to really think about the suite of species that eDNA can detect, and thinking about the reference libraries that we need, and are they vetted? Do we have the proper sequences? And coastal versus offshore pelagic communities, developing that out, an eDNA system as well, could be very helpful and beneficial going forward. So.
Great. Thank you for those perspectives, Tim and Andy. Scott, thank you for your patience as we unmuted you.
Yeah, you bet. No problem at all. Thanks very much. And wonderful presentations. Great job, Becky, for organizing this. And so I think my maybe mostly just a comment, but sort of a question to either Tim or Pat is, and actually I asked or made this exact comment a few weeks ago at the Intergovernmental Task Force in the Gulf of Maine, is so those are great data sets that you guys are talking about related to migratory birds, of course. And however, what seems to be lacking though sometimes in these presentations are the tracking work that we do with either radio telemetry using the MODIS network or satellite telemetry. And I know that apparently the data sets cannot be combined. So the presentations that were made were great for the survey work, but it feels like many times in these presentations we're lacking some of the tracking work. So I think that would be a really important addition as we're moving forward on presentations like this. And Tim, for example, BOEM and others in the States, of course, along the Atlantic have invested heavily in satellite telemetry and radio telemetry work. So maybe just either a comment about moving forward, like how do we best present that information since we're not able to combine it into these existing survey data sets?
I mean, that would be useful if we could have one database that could have aerial shipboard surveys, and then maybe another segment of the database that would hold tracking data. But I think the analysis, it's complicated, it's complex to integrate the observations with the satellite tracks, but not impossible. There are different ways of doing that. I think we should look into more how to integrate those, because I think the satellite tags, and they're both informative. They're individual based models, but the satellite telemetry can boost the inference of the observations.
Right.
Actually, getting it, we should do better at getting some of those slides into our presentations. Likely.
Yeah, that's right.
There's a lot of different teams out there. For this AMAPS and federally funded these federal projects. It's at a high level, it's easier to present those and kind of going to the different teams and pulling in, there's a lot of people out there with different types of tags and doing this type of work. So I guess it's a little bit more of a challenge to try to get that all on one slide, but I'll take that and take your advice and try to do that.
Well, right. Yeah, exactly. And sorry, just a quick follow-up is right, exactly, because I don't think the data sets can actually be combined, but it's certainly a critically important source of information, I think, for migratory birds, because obviously, as we all know, this is identifying use of habitat at night or in bad weather, et cetera, when surveys are not able to be completed. So it's really just my point, I think, is that we're missing out on a really critical data set, particularly as we're moving offshore with some of the receivers either being put on turbines, met towers, and even on buoys too. So, the MODIS network obviously is largely land-based, but as we're moving offshore, that's giving us, I think, much better data in more of a localized sort of an area. So thanks very much, Becky. I really appreciate it. Nice job, everyone.
Absolutely. Pat, I have a feeling your perspectives on this.
Telemetry data is fantastic. And we didn't, in the 10-minute presentation was just really trying to focus in on the application of the line transect survey types of data. But telemetry data really provides a wealth of information that's slightly different. It gives us a huge amount of behavioral information. It lets us know what the animals are doing versus just observations that they're there. And so for wind applications, telemetry data at a broad scale can allow us to look for gaining more information on the seasonal patterns and shifts and changes in migration patterns. But at the finer scale, actually a lot of the work that's being done to look at in our kind of risk framework at the bottom of that risk framework, which I didn't talk about, which is looking at the actual effects and consequences. It's actually telemetry data that really informs that. It's like, are the animals displaced? Are they changing their feeding behavior? Are they moving? And that's where that fits in just in spades. So, so really, I was just focusing on the regional scale models to give the context, but telemetry data has a huge component to play in this game.
Great. Thank you, Scott, for the question and for those responses. I think we have time for one more question before we move to closing. And Andy, I was thinking maybe you could vocalize the question that Roger asked in the chat and your response about what are your thoughts on taking advantage of the offshore wind energy infrastructure itself to establish a network of sensors? Certainly a question that's being asked in the community all the time and that everybody's working around, but I'd love to hear your response and certainly Tim or Pat as well.
Yeah, Roger is a counterpart of mine at NOAA Fisheries, who's at the Southwest Fisheries Science Center. And so I want to thank him for reminding me of what I didn't say in my earlier response, which is there are constraints when you want to build an energy project, you want to produce energy. And so there are constraints to attaching or instrumenting turbines or the cables themselves. Those are the, the turbines, the cables, the substations will have power, data, and we're developing a massive backbone of potential ocean observations. And this is where that slide I had where I defined what collaboration is. It's not just the federal government saying you're going to do this. We need to work together to look at, can we do this? What are the constraints to doing this? I know that from what I understand in Europe, there's significant liability and risk associated with other entities using offshore wind developer infrastructure. But I'm sure we're at an early phase in the US. We started pile driving, I think this week at Vineyard Wind. We get 7 turbines in the water. It's not too late to work out some of these details. But it would be a shame if we didn't turn this stone over as much as we can.
Great. And Tim or Pat, do you have any thoughts on actual instrumentation of the offshore wind energy infrastructure?
We are in discussions with developers on pushing that envelope and having good conversations. There's, a lot of potential issues over risk and things like that. But from the academic community and scientific research community, we're definitely pushing to see what's possible, because there could be instruments that I think, would be low maintenance and low risk that might be extremely helpful. We also have to work out statistical biases that could be, putting instruments on turbines creates its own patterns, but I think there's a great opportunity there. I also do think there could be benefits for if you're trying to look at questions of potential net gain in ecosystem services, reef effects of turbine pilings and things like that. Actually being able to monitor that and show that and demonstrate that is something that would require us to actually have monitoring that's very close or on the actual hardware itself.
I'll just echo what Pat and Andy had said. We're always looking into these technologies. When we think about birds, tropical migrating birds or trans-Gulf migrants, concern is what's the impact, collision risk, as they move through the Gulf twice a year, or up the Atlantic seaboard, down the Atlantic seaboard, fall, spring migration. So technologies like next-red radar that we're working with Cornell University now to push those birdcast models offshore. That's a study that I'm working with them, Andrew Farnsworth, on to get inference of what those beams tell us as far as migratory birds are concerned over the ocean and intersections with the wind energy areas. And there's a study I'm doing in the Gulf of Mexico with USGS using mobile radar, potentially on offshore platforms to get at more localized flight height of the trans-Gulf migrants. So 5 or 6 of the radar units on the platforms and on ships of opportunity as well, on NOAA vessels, to get a baseline of bird flight height. And other technologies and thermal cameras and acoustic monitoring for birds to break down. So to get an idea of the spectrum species distribution. If we have a radar, say, or next rad, we see bird-like scattering, but we don't really know the composition, species composition. Passive acoustic monitoring could get at that a bit as well. So these are all things that are on our mind. We're looking into.
Great. Well, thank you. And we're getting very close to the end of the hour. So I really wanted to thank each of you as panelists and speakers today for all of your time. And certainly I wish we could stay on for another hour and continue to discuss this topic. I do want to go ahead and close. This was the first of, as I said, a new SEER webinar series that we're putting on this summer. The next webinar will be on recent advances in autonomous monitoring technologies to support offshore wind energy development. So we'll be able to continue some of the discussions that we started today. The third webinar will be on emerging technologies and infrastructure for monitoring bats and birds offshore, some of which we also started to talk about today. And finally, the final webinar will be on environmental considerations for nearshore ecosystems, from cable landfall, navigation, and port development for offshore wind energy. So we certainly look forward to your participation in those upcoming webinars. And with that, I would again very much like to thank our speakers, Andy, Tim, and Pat, everybody who's participated today, certainly our DOE sponsors, and we very much wish you an excellent rest of your day. Thank you very much.